My name is Daniel Crowley. I work for Spider Labs. Let's just dive in. So, one quick note. I'm a web application security guy. That's what my focus is. So this talk is going to be sort of centered around applying these concepts inside sort of a web application-centric world. I'm not a cryptographer, but that's okay because these attacks can be used in such a way where you don't need to know about the underlying crypto. Although, obviously, if you know more about it, it's going to help you. Should you want to contact me, my contact information can be found here. And these slides should be on the CD as well, so groovy. So the presentation topic is about encryption or about cryptographic oracles. We're going to be talking a little bit about encryption oracles, decryption oracles, and padding oracles, which are generally used as decryption oracles and also as encryption oracles in certain circumstances. So, like I said, little to no cryptographic knowledge is required. I'm going to be going over some basic terminology, some basic concepts. So if you don't know anything about crypto, well, I'm kind of surprised you decided to show up to this talk, but thank you. But I'm going to try to cater to you as well. So, good stuff. So let's talk about some things that are not the presentation topic. So we're not talking about the oracle. We're not being harvested for energy by robot overlords. Possibly. We're not talking about the company Oracle. Fun fact, if you Google for any crypto word followed by Oracle, you'll probably find Oracle folks asking, Oracle users asking how to encrypt their database. We're also not talking about Google, the Internet Oracle. We're not talking about cryptographic gurus like A.D. Shamir. If you don't know who Shamir is, he's the S in RSA. Also awesome, but not the topic. We're not talking about new attacks on old crypto. I will be clarifying some details on the default encryption algorithm in Cold Fusion, but that's not exactly a new attack. That's already known. It's just I've never seen it made public. I wasn't able to find any public details on why Adobe says this is a weak cipher. No, stay away. We're also not going to be talking about how padding oracle attacks work. Now, if you would like to know, the presentation from Echo Party, Padding Oracles Everywhere, is a fantastic resource, and it talks about the implementation with both implementation of padding oracles as decryption oracles and using that against a couple different things, Java server faces, ASP.NET, so groovy stuff. So I'm also going to drop little bit of Ode on the DEFCON drinking game, which is where you listen for buzzwords in presentations and then drink when you hear them. So APT iPad, APT China Cyber War, Cloud Mobile Botnet, Cloud Cyber Twilight, APT Sun Tzu, RSA HB Gary PCI SCADA in the cloud, Cyber War, LOLSEC, APT China Cyber War Weeaboo, WikiLeaks Mobile LOLSEC. So now that you're nice and primed for this talk, let's get into a primer on cryptographic terms. So some very basic stuff here. So a cipher is just a system for mathematically scrambling data that you want to be hidden from certain parties. So a cipher is a system for scrambling and unscrambling data. The key is the one part that you keep secret. The key is the part that the sort of missing variable that somebody needs to know in order to be able to unscramble the data. The initialization vector is used in a similar way, but it's not always necessarily private. The idea of the initialization vector is almost as a second key, which doesn't necessarily need to be private, although in a lot of cases it should be. The point of the initialization vector is so that when you encrypt the same thing with the same key, you can change up the initialization vector and the ciphertext won't look the same. Now, getting onto that term, plaintext and ciphertext are the unencrypted and encrypted versions of the message, the human readable and unreadable. And encryption and decryption are turning plaintext to ciphertext and vice versa. So we can split the set of ciphers into stream and block ciphers. Now, if there are any cryptographers out there, maybe there's something else that I'm unaware of, and I apologize about that. But as for stream and block ciphers, with a block cipher, you take a chunk of the data, you take the message in chunks and encrypt each of them one by one. So the key is used directly to transform the plain text into the ciphertext. Whereas with stream ciphers, you're encrypting one character at a time, one byte at a time. And the key is used as a seed to a pseudo-random number generator. It might be worth mentioning what a pseudo-random number generator is. It generates numbers that look random but are not. For instance, you can use hashing algorithms as pseudo-random number generators. So you can use MD5 and just hash something repeatedly to generate a series of very predictable but random-looking numbers, things that are hard to predict, but if you feed the same password in and iterate through MD5 1,000 times, you're still going to end up with the same hash, the same set of numbers. And then those numbers are used to transform the plain text into ciphertext. So let's talk about some basic mistakes. One, using a keyless cipher. If you're using a keyless cipher, it is not secure unless it's totally private, unless nobody else knows how the algorithm works. And even then, it's probably not very secure. Also, reusing keys and initialization vectors. That's a bad idea, and we'll see that shortly. It makes Oracle attacks far more dangerous, and it can also serially